Hi guys, I will be talking about VLIGHT FAST. VLIGHT stands for VLA Low Band Ionospheric and Transient Experiment. The FAST is actually nothing but a search engine for FRBs, RRIs, pulsar, single pulses, the whole transient searches. In a typical VLA antenna, the primary observers have their frequency starting from gigahertz, and what we search in is megahertz. So the gigahertz electromagnetic waves reflect off the primary dish, and then also reflect off the primary reflector, and then have their feed starting at the Cassegrain focus. But the megahertz waves have their feeds at the primary focus, and this is why it's a fully common hardware level commensal system. And we have this system, the speed and 16 antennas, and they offer a bandwidth from 320 to 384 megahertz, and in the P band. Some of the silent features of VLIGHT FAST is that it has already recorded around 125 days of on-sky time, which amounts to around 50% of uptime. And it has an instantaneous bandwidth, instantaneous field of view of 2 degrees. And it can also perform imaging and localization with voltage dumps. And in A configuration, the angular resolution is around less than 5 arc seconds. And these are some of the pulsars that were detected with the VLIGHT FAST pipeline. And the pipeline is as this. Each antenna gives out UDP packets, which are captured by a writer, which writes it to a ring buffer, which are processed by a GPU code, which is known as process baseband, which filter banks it. And there's an MPI coadder, which coadds it across all the antennas to produce an incoherent beam, which is searched by Heimdall. We also have an indigenously developed convolutional neural network machine learning solution, which determines if a given trigger is good or bad. If it's bad, it doesn't do anything. If it's good, it triggers the dumps. And sometime in April this year, we had a fortune of detecting an ISFRB with a DM of 212, SN of 11, and width of 6 milliseconds. This is the trigger plot. This is the candidate plot, which we call. And to the right is the time profile and a Dirac pulse convolved with an exponential tail to determine the scattering. And if we apply the electron density model, we report an XSGM of 190 to 192. And this is my email address. So if you have any questions, feel free to ask. Thank you for your attention.